Welcome back to freehighschooleducation.com. Today we are going to do chapter 7.5 in Algebra 1, two special cases of factoring. The first special case is the difference of two squares, and the general formula is a squared minus b squared. Here we have two numbers. There is a square minus another square. An example of this is 4x squared minus 49. This is the square of 2x, and this is the square of 7. Now the way we factor this is as such: sum times the difference, and we have seen this before, and we call these conjugates. So when we multiply these two binomials, we get a squared minus b squared. Applying this to this polynomial, we are going to get the sum of these two numbers multiplied by their difference. And we should be able to recognize this format and be able to factor it. Now the second special case is the one of the perfect square, and we have here two cases of perfect square. The first one is a squared plus 2ab plus b squared, and this factors into a plus b squared. A plus b multiplied by a plus b. And here we have the square of the first, the square of the second number, and double their product. In case this is negative, then we get the second case of this perfect square. Again, this is a perfect square. We are multiplying a minus b times a minus b. Except that this time, double the product is negative. It's still b minus b times minus b is going to give us a positive b squared. So let's have some applications. On page 260, we have an example for x squared. And we'll use 12x positive instead of minus as in the book, plus 9. This is the square of 2x, and this is the square of 3. And let's see if this is double their product. So 2 times 2 is 4, that gives us 4x, times 3, that gives us 12x. So this is a perfect square. So we can factor this as such. Now, if this is if this number is negative, then this should be negative. And in this case, we are going to factor this also as a perfect square as such. So it's going to be 2x minus 3 times 2x minus 3, and that will give us this trinomial. So this is the perfect square trinomial, and with this we come to the end of this session, and we hope to see you again.